Let's start with a brief introduction of who we are. We are a digital research infrastructure based at the University of Zurich, where we provide mutual, unified, and tailor-made access to high-quality research resources in the domain of art history, history of architecture, and digital humanities at large. We also have the status of technology platform at the University of Zurich. In this function, we provide our expertise in semantic technology, project development, and data processing services. Among our clients are the SAPA Foundation, Swiss Archive of the Performing Arts, and Zentralbibliothek Zurich, Central Library of Zurich. To make this presentation somewhat entertaining, I have decided to introduce some movement into the picture, that is, some references to the movie Wizard of Oz. To sum up the story and to make the illusion somewhat intelligible, girl Dorothy and her dog Toto were sort of teleported to a magic land of Oz, where they had to follow the yellow brick road in order to find the magician who would help them to make their wish come true and return home. Let's stretch this metaphor of the yellow brick road a little bit further and see how the road to link data is being paved.
Follow the yellow brick road. Follow the yellow... Now which way do we go?
Pardon me. That way is a very nice way.
Who said that? Don't be silly, Toto. Scarecrows don't talk.
It's pleasant down that way, too.
That's funny. Wasn't he pointing the other way?
Of course, people do go both ways.
Together with the growth of digitized collections in the cultural heritage domain, the need for consistent and efficient workflows for normalizing, transforming, analyzing, and representing such data increases. Knowledge graphs have a big potential as a way of creating linked data across archives, collections, projects, and even domains. But of course, not without challenges. One of the first challenges that we would like to address is a conceptual one: formalization of data. How does one do it? It is not an easy task if one has to do it consistently across large scale. We work together with domain specialists and computer scientists to find common grounds here in connecting image data, text data, metadata in a meaningful and efficient way in order to produce knowledge graphs. Another challenge is more of a technical and inter-institutional matter. How does one unify myriads of standards and data sources in a consistent data flow, both in human and machine-readable way across collections and institutions? For our project, we work with a wide range of source data, including XML files, Lido files, CSV, and Excel files. Another important point is that work with knowledge graphs requires a high level of interdisciplinary expertise and experience. Knowledge graph engineers have to understand data, as well as domain specialists need to understand processes of data transformation and computational analysis techniques. So how do we address those challenges at SARI?
Rub here, rub there, whether you're tin or bronze. That's how we keep you in repair in the merry old land of Oz.
We can make a dimple smile out of a frown. Can you even dye my eyes to match my gown? Uh-huh. Jolly old...
Our data pipeline consists of manageable chunks of work which include automated, semi-automated, and manual, almost artisanal practices. We start with creating a data model for a project by defining data fields in accordance with SIDAC CRM standards and its extensions. Our data model is also compatible with linked art. As a knowledge base, we use SARI data reference model. The documentation is online. There you can find a list of entities, entity descriptions, as well as knowledge patterns. It is used to guide mapping processes and represent common mapping patterns to design interoperable data structures, which potentially can be fed into a larger aggregation of cultural heritage data. For actual data transformation, we work with X3ML editor, which allows us to map entities into our target ontology with the help of the mapping files. This ensures consistency and reusability of data across different datasets and collections. Next step is to align data with external reference data. We have developed reference data services, RDS, which enables querying data across multiple reference datasets such as Wikidata, GND, AAT, ULAN, and GeoNames. There is also a possibility of using RDS for individual projects. Such instances are called RDS local and then feeding the data back into a global RDS instance. We also align data with custom scripts. For instance, here you see the output of a Jupyter notebook in which we have incorporated and aligned SwissTop references. So what the map shows is which GND and GeoNames identifiers are available for municipalities listed by SwissTop dataset. Next step in our pipeline is data enrichment. And here I would like to briefly introduce you to our pilot project, Bilder der Schweiz online, or Images of Switzerland. It includes approximately 28,000 objects by now, representing prints, aquarelles, photos, postcards, covering places in Switzerland depicted from 1700 to 1950. Even though we are still working on the platform, it is already accessible online. Our production instance can be found under bso.swissartresearch.net. So please have a look for yourself, explore. There are quite some interesting entities out there already. And so now I will just briefly let you know how we enrich data in that project in particular. So we use computer vision algorithms for image similarity. On that platform, we use it, for example, to spot duplicates. We also use image similarity and clip algorithm to define whether some images have content similarities, and we also explore text similarity a little bit with Jacquardian distance in order to find similar titles of artworks. And I have made a quick screen recording for you to see whether Mendrisio is well represented in our data sets. So we use the global search first to look for the place Mendrisio, and then here we have the list of artworks represented. So I chose this one, the Church of St. Martino, and you can see that the results are rather sparse. There is no visual similarity or similar artworks by title, but some entities are similar by style, let's put it this way, or by what is drawn on the picture. So I encourage you to explore our platform and look for yourself what is out there. This was a brief introduction into our current pipeline and data transformation practices. Thank you very much for your attention, and we are looking forward to share with you our updates in the future. And please don't forget that behind all of these pipelines and algorithms are always people. Thank you.
Oh, the great Oz has spoken. Oh, pay no attention to that man behind the curtain. The great Oz has spoken.
Who are you?
Oh, I am the great and powerful Wizard of Oz.
You are? I don't believe you.
No, I'm afraid it's true. There's no other wizard except me. You